रोहित जी। रोहित, आवाज आ रही है?
यस सर, यस सर।
मैडम ने ज्वाइन कर लिया है, उनको को होस्ट बनाइए।
डन सर, डन।
डन, ठीक है। मैडम नमस्कार, राम राम।
गुड इवनिंग।
मैडम विदिन विदिन 4 मिनट्स हम लेक्चर स्टार्ट करेंगे, हमारे पार्टिसिपेंट्स ज्वाइन कर रहे हैं।
ठीक है।
ठीक है।
आज बनने जा रहा है स्वाद के लिए आंवले का मुरब्बा।
नंदिनी, आप अपना ऑडियो और वीडियो देख लीजिए, सब क्लियर है?
ओके सर। हम्म।
ठीक है, डन। एक बार रजिस्टर्ड पार्टिसिपेंट्स के ग्रुप में फाइनल रिमाइंडर डाल दीजिए कि विद इन 2 मिनट सभी पार्टिसिपेंट्स ज्वाइन करें, फिर उनकी अटेंडेंस ले लीजिएगा आप, ठीक है? कर दीजिए। अभी शायद 230 लोगों ने ज्वाइन किया है। ठीक है। नियर अबाउट 300 हो जाएंगे बस, फिर हम स्टार्ट कर देंगे, ठीक है? 1 1.5 मिनट में ज्वाइन करने चाहिए, मैंने भी रिमाइंडर डाल दिया है।
मैम की पीपीटी शेयर हो रही है?
मैडम से रिक्वेस्ट कर लीजिए कि पीपीटी शेयर कर दें।
मैम, could you please share your PPT as well so that we can check if it's visible or not? Is it visible?
डन,
Yeah.
विजुअल।
Shall we start then?
आप स्टार्ट करिए नंदिनी जी.
Good evening, everyone, to all the respected dignitaries, distinguished speakers, mentors, and participants from India and abroad. Welcome to day 19 of International Winter School Bharat 2025. I am Nandini Sharma, Assistant Director HR, AgriMeet Foundation Bharat. Today's session is done by Dr. Sunita ma'am, and we are very much honored to welcome her to Bharat 2025 with the theme Boosting Holistic Agriculture Through Research, Awareness, and Training. This platform brings together ICR institutions, universities, and partners to translate science into scalable solutions. Our focus spans breeding pipelines, climate resilience, and data enabled decision support, empowering researchers and practitioners across every regions and beyond. So it is a complete honor to introduce Dr. Sunita Chaudhary, ma'am, scientist, system analysis for climate smart agriculture global research program, accelerated crop program at IGRISET. Her expertise includes crop physiology under abiotic stresses and translation of high throughout phenotyping insights to improve drought, salinity, and heat tolerance in cereal crops. She is a well-qualified scientist who has done various works and work for the establishment of the nation as well. Dr. Chaudhary's research spans C4 cereals, pearl millet, sorghum, and maize, targeting broad adaptation across agroecologies with strong expertise in precision phenotyping and grain nutrition quality assessment. She has contributed to drought tolerant product delivery through public private collaborations, supervised PhD, masters, and intern scholars, and published over 20 research papers and multiple book chapters. Her work leverages UAV, drone sensing, imaging, and sensor based platforms to accelerate trade discovery and selection. She is a certified drone pilot under DGCA and advances UAV applications for sustainable agriculture. She also contributes to modeling workflows that evaluate climate risk and support crop improvement decisions across cereals and legumes. On the behalf of AgriMeet Foundation Bharat and UGC MMTTC Jodhpur, it is a privilege to welcome Dr. Sunita Chaudhary to day 19 of Bharat 2025. We look forward to her insights on climate smart physiology, high throughout phenotyping, and modeling tools that shorten breeding cycles and strengthen farm resilience. Over to you. The session is yours, ma'am. Thank you.
Thank you so much, Nandini. Can you confirm if my screen is in display mode?
Yes. Yes, your
Yeah,
screen
it
is
is
visible.
visible.
Thank you so much. Thank you very much for this opportunity. I'm really happy to be part of this and got a chance to address the bigger audience, especially the young generation about that. So when it comes to holistic agriculture, I chose like we work on many things. So first of all, I would like to introduce a little bit different than what Nandini has almost covered everything. So we at ICRISAT, the research dynamics is expand in every direction. So I cannot claim if I, by training I'm physiologist, but we don't work just on domain area. Wherever research can make an impact to, especially to drylands, we expand in that area. So while working as a physiologist over time, we have to adapt for the sensors, which can give the way physiologists do the measurements that may not help breeder. Breeder deal with thousands of lines. We work on 5 lines. So that way it doesn't serve the purpose. So over time, physiologist and everything has evolved where it can make an impact. It has to serve the breeders and breeder has to serve the reasons or the farmers who are the ultimate target. So what we do, we study environment. We do crop adaptation studies like tolerance and all this. Apart from that, we also provide a platform where large scale screening is possible. When it comes to large scale screening, you cannot do with normal conventional methods. You have to go opt for the sensors. Sensors are the beautiful technology. And when it comes to sensors, to harvest the maximum benefit out of sensors, you have to integrate with AI. If AI is not there, sensors sensors can only give you spectra or images or some kind of digital data, but that to convert into data which is useful for your breeding, you have to integrate AI. So this is how we have evolved. I chose topic on nutrition because I feel this is very much lagging behind. We have achieved a lot of progress in the increasing the yield. Almost all the crops have more than 100 years of breeding, except some new crops. And over time, through conventional breeding and also integration of technology, now breeding has achieved a good success where yield is improved. But what happened to nutrition, we don't know. So this my talk is today is all about that nutrition. So I have kept very simple title, nutrition inclusive breeding. I'm sure most of the like some of the audience in this training group will be breeder and they will have some benefit. Or if the young generation focus keeping nutrition in their breeding selection pipeline, so that can serve the nation. So overall, I think I have already briefed. I'm going to talk about nutritional gap, why we are focusing on nutrition. Then we are going to talk about the rapid, how we can do it faster, and what benefit we can get out of it, and how to integrate into normal breeding pipeline. So approximately, like, what was the perspective 50 years back? Like, if we see the hunger and food shortage was too high, so breeder has to focus on the yield improvement. Almost 35 to 40% population face chronic hunger in 70s, particularly in Asia and in Sub-Sahara Africa and Latin America. Productivity was very limited. Like before, I'm talking about before Green Revolution, and the population, significant proportion of the population was relying on the subsistence farming, means the very localized farming. Always we see famines, and those were very much part of the and every 10 years, 20 years, they were very much part of the life. So obvious choice that time when hunger was so widely spread, the breeder obvious choice was to increase the food productivity, increase the yield. So there is no claim that nutrition is ignored. 50 years back perspective was that just like that we have to increase the productivity. So what happened in 50 years when we started focusing on increasing the productivity? At present, if we compare, so 1960s, 225% we have increased the yield productivity in wheat. Similarly, in rice, 146% we have increased the yield, which is a really great success. In maize, around 200% we have increased the yield. Dryland crops are also not on the back. With the hybrid technology, pearl millet, you can see that maximum benefit they have benefit we got out of pearl millet hybrid breeding. So success is quite good. As per record, global population has also increased and hunger has reduced. So somehow we are very successful in accomplishing the mission. But then question is like, over 50 years, what happened to nutrition? And nobody has proper data that that time protein percent was this and we have improved to this. If you search your internet or if you search books or papers, there is no proper data because the focus was not nutrition. But somehow the data on the malnutrition or nutritional paradox shows that the nutrition problem has increased. So somehow we have ignored the nutrition content in our while increasing the yield. So you see that the problem is everywhere. None of the continent are spared. And this paradox, like overweight, also just to let you know, overweight is not a good nutrition. It is also a bad type of nutrition problem. So overweight is not counted as a well-nourished body. Nutrition challenges are increasing day by day. And if we see undernutrition, micronutrition, also we call hidden hunger is there, overweight, obesity, and diet-related non-communicable diseases are also increasing. WHO fact sheet is also quite full of things which is like keep on increasing. If we see through map in children, young children, the problem of anemia, which is iron deficiency, is quite widely spread, especially in Africa and Asian countries. And 15 to 49 years also, they are now also very quite anemic. So the whole map, world map is colored. So that means like we have a problem. So it's not like nothing has been done for nutrition. Some selected program has been done, like biofortification in wheat. We have done zinc and iron increment is there. Rice, golden rice, vitamin A rich rice has been released. Maize, high quality protein maize has been released by CEMET. Even in pearl millet, which is already nutrient crop, but then also they have tried increasing the zinc, and sorghum also biofortified. But problem is that these biofortified programs were not running as a regular breeding pipeline. They were running separately, where yield was not a concern, and that's why the adoption has not happened for this high nutritious crop. Obviously, if you give a farmer a choice, high yielding variety or high nutrition variety, they will go for high yield. There is no question about that. Everybody wants to improve high yield, improve the yield, because that is the economic benefit to them. And in India, there is no formal market for high nutritious crops. So why farmer will opt for this biofortified products? So why breeders have not taken nutrition in their regular breeding pipeline? Why nutrition, like when they select from one generation to next, they select for disease, they select for yield, they select for some economical benefit traits, they select for insect pest resistance, and sometimes for drought also, but they never select for nutrition intentionally. So there are certain things which is very obvious. Adoption of poor adoption of biofortified is like that. Then genetics is not very simple for all the nutritional trait. Stability is not there, and then when they advance one generation to another, is always time sensitive. And if they have to go for nutritional analysis of that, it will take months and months. Breeder cannot wait for that. So these are the some obvious reason why they never select for nutrition. So selection for nutrition regularly is not that difficult. We can do it, but depend on what facility you have. So usually these time sensitive things are like not considered very prominent, but we realize this time sensitiveness is one of the major challenge. If the breeder produced the data on yield and all those disease pest resistance in whatever time, in same time, if we give the nutrition data, probably they will select for nutrition also, or they keep in the list the high yielding with nutrition. So this is one thing. And then we thought if we go with wet lab, probably we cannot meet this kind of faster assessment. So we started looking for what are the next generation technology which can give me nutrition assessment very fast. So if you see wet lab, like it takes months and months, and many of the institution has adopted this benchtop sensors, like ICRISAT from last 2 decades working in this, NIRS, XRF. These are the sensors which can give you, without any chemical reactions, it can give you the nutritional values. If you develop a calibration, there is a process for that. But once it is established, it can give. But that also take a days, and you have to still harvest, dry, and grind the samples. Sometimes non-grinding is also working. And then we are now working on portable device. So you need not to grind also, like, and the prediction is very instant. It's in real time. This portable devices, it will not only help the breeding program, but also the value chain. You can take it to market. So India has very decentralized market. So if this can trigger a quality-based pyramid, it will be a big success. Although government is working towards this, and ENAM initiatives were associated with this kind of portable devices. So these are the sensors which I'll brief you in my coming slides, but just a overlay of all this, overview of all this. So we are using NIRS, which is near infrared spectroscopy, and Raman-based technology. This is sensor names. So this mostly for organic, like if you have protein, starch, fat, oil, fatty acid, this kind of trait assessments. which is organic in nature, which composition is carbon, hydrogen, nitrogen, and oxygen. This kind of traits you can easily do with NIRS technology. If you want to assess inorganic like iron, zinc, calcium, which exist in inorganic form, then XRF-based, X-ray based technology is like fluorescence-based technologies are very, and portable versions are available for both. Some of the post-harvest traits also, which is not nutritional, but then they also play, they are the indicators of your nutrition. So for that, we are using computed tomography based technology. Just 2 slides I have kept, and Harvest Master, which is also a sensor, very portable sensor. You can take it to field, battery operated. So the time you harvest, you can assess for moisture and density test weight, which gives you that healthiness of seed and also correct your yield for the moisture. Sometimes your yield is not corrected for moisture, and then sometimes it is misleading, like yield of the different varieties while selection. So coming to NIRS is a benchtop instrument, you can see, and it has a potential to do 250 samples, like 250 genotypes can be assessed in just 1 day working hours. And it's a one-time investment you have to do in your machine, and also one-time investment in developing the calibrations. Calibration again based on the wet labs only. But if you go for Zeldal method, which is a most common wet lab method for crude protein, you can only do 8 samples. So see the difference. Rapidness cannot come without using the sensors. 8 sample, how many machines you can keep and how many people you can employ, and then chemical, and that they are expensive, they are time intense, like time taking. So this is the advantage why we are over the sensors. So just if you want to understand, so NIRS range from 400, actual range is 1100 nanometer to 2000 nanometer, 2500 nanometer, but machine what we are using is covering the visible range, which is 400 to 2500 nanometer. So sometimes color differences, if they are associated with some kind of nutrition benefit, that also helps. So machine brings the robustness in your calibrations. This can work on grain, on fodder also. Fodder quality is also very important for livestock nutrition. So we take it for both. This machine can work. ICRISAT sometime back in association with our national partner released the high oleic variety Girnar 4 and 5. And this mission was not accomplished if we were not having this NIRS machines. Every season we were receiving 7,000 samples from their different breeding programs. And the product what has been launched, Girnar 4 and 5 in groundnut, that has a 80% oleic acid. Compared to the local one, K6 and all this, they have hardly 40% of oleic acid. And that this also reduces the linoleic acid, which is the bad cholesterol. In simple word, we will say, if we go scientifically, it is a bit different. So bad cholesterol fatty acids are like reduced to 20%, even less than 20%. So this is the difference, like high oleic, high nutritious groundnut release is possible only because NIRS was there. Otherwise, imagine 7,000 samples, sometimes 5,000, sometimes 3,500 samples doing in less than a month time. Like, it's not possible with the wet lab instruments, and probably this kind of release. And also Girnar 4 and 5 has a very competitive yield. It's not it's lower in yield compared to the checks. In fact, it was little higher towards the yield. So this is the breeders, new generation breeders they are doing. They are combining yield with nutrition, and they are not, there is a obvious, like there is a thought that the nutrition and yield is negatively correlated, but it's not. It's case by case basis you have to see. It's not a general assumption. It's not a general rule. General assumption is there, they are negatively correlated. Breeder doesn't, usually they don't opt for this, but I really want to use this platform to message that they are highly unrelated trait. Only maybe sometime if you find, that's okay, but that not for everything. So we can still improve the nutrition along with the yield. So second example is mustard oil content. So now not only ICRISAT doing the in-house sample, but also from companies, we are receiving a lot of mustard samples. So when they harvest and they have to take it to next generation, they hardly have 1 month time. So that time we receive. So for oil assessment, you have to use Soxhlet method, and the best Soxhlet machine can only take 4 samples per day. So if you have to generate for 500 sample, it will take 70 days with quality control. So some repetitions you have to, some checks you have to use. If we do with NERS 250 sample, I can scan and generate data in just 2 days, but I keep 3 days extra just for quality control. I ensure when I'm giving a data, it is like very close to real, so that the readers doesn't have disappointment. So ensuring your calibration, your quality, this machine can serve best. So this is something germplasm. ICRISAT has the largest gene bank in India, and we have like almost maximum 22,000 accession of sorghum. Out of that, meaning core collection of 3,000. When we screen, we found that if you see the fat and protein, when protein enhancement breeding programs were doing. So these are the land races collected in 1963 to 1981. And these are the exotic collection, pink one. These are the some lines which were like intermediate line and bulk are there, and current elite lines we have taken. This is the density gradient box plots. So you see that now the current breeding material is able to increase the protein and reduce the fat. But if you see the old land races, they were high in fat and lower in protein. So that means the breeding is progressing in right direction. The protein enhancement is happening. If we wanted to see this 3,000 we did in very short time, in a 10 days, I think 10 working days. And then when we checked whether the high protein lines are coming from different location, because these are all geotag collections what we have in GenBank. You can see some of the regions in Africa, they have a genetics of high protein. High protein is also some associated with high nitrogen use efficiency capacity of the plants genotypes. So although sorghum has a lot of species, subspecies, caudatum, bicolor, and they have different in their capacity to extract nitrogen, but this comes from very marginal land. So this kind of things are possible. So if I have to brief a little bit about how the sensors work. So sensors work like when you buy this benchtop, they are just a black box. They have sensors, but do not expect that they will give a calibration. You will scan a sample and you will get a data. This will not happen. Calibration you have to develop on your own. I need a protein, I need a fat, but some other people may need amylose, some other one need amino acids, someone need vitamins. So it's purely based on your requirement. You can develop the calibration whatever you want. So to create a calibration, if you have 1,000 samples, you take 100, the maximum diverse sample you take. So I screen, if the diverse mini core collection is 200, I screen all of them. And then based on a spectral signature, I select the most contrasting type or the subset from each range. And that out of 1,000, only I will make a subset of 100 samples, which will go for wet lab. This is one-time investment. Only in the beginning, you have to do one time. And those 100 sample wet labs will come. Then you use only 70 or 50 samples to create a calibration. Keep your 30 samples for just for blind validation. So when you create a calibration, it also does auto validation, which doesn't have the blind sample. But once your calibration is created, calibration is an equation which creates that if this kind of peaks are there or this kind of bonds are there, then this much protein it represents. In very simple term, if I have to explain, then this is the word. But although scientifically it is very elaborated. So once calibration is created, then blindly 30 samples which you have kept not shown to machine, you validate. If your validation is above 0.95, then you ensure that your calibration is working. If it is lower, then you have to improve your calibration model. So we repeat until we reach a satisfactory level. I agree that some traits are not simple, like starch is not simple, and achieving 0.95 is highly difficult. So if those complex traits, if you achieve above 0.8, that is also good. So depend case by case basis, but you have to ensure the quality, you deliver the best. Otherwise, the people belief on the sensors will go off. So this is how we do, like you see the prediction and then our reference. So it is very close. In this kind of things, you are happy with calibration, then you start predicting. So just a base, we make sure that the spectral signature has the sufficient variation, your samples has a sufficient variation. Wet lab is very good. Sometimes your wet labs are not good. If your wet lab, when I say wet lab, means the chemical based method, you can analyze with any lab or your institution in-house labs also. So if that data is not good, then the whole calibration is like misled. You can never achieve a good calibration. So you have to make sure that you send the sample for wet lab only to trusted labs, and always send the samples, some sample 5 or 10% of sample in duplicates, so that you can check the quality of your wet lab. Duplicates, triplicates you can send, so that you know that, and always repeat the higher and lower side. So this is how you can ensure the quality. Wet lab has to be very, very good. Then once we scan the samples, there is spectral signature capture, and which is pre-processed. Primary and secondary processing happens. So this is machine does, need not to worry about. Then you build and train the model. So your calibration training set, you can see this is, you are seeing the multi-species calibration model. So cereals and legumes, all we have taken, and you see the validation statistics is quite good. And then when we did the validation, that is also like quite good. Once we achieve this kind of calibration, you are set to go. So this optimizing tech, not only for breeding, for value chain also. So that's why we work on portables. Although achieving the high accuracy with portables, sometimes it is challenging, but because the spectral range is like, it only capture from 1100 to 2500, but we try to make it as much as portable one can directly kept on the grain and can also scan and give approximate values. So this portable one has its own advantage. It can be used in industry grade, in market, those quality-based payment, as I introduced in my introduction, I mentioned. Those kind of ENAM initiatives can be served with this kind of, they are very handy, like a palm size, or sometimes just like 15 centimeter sensors. Battery operated, you can connect with your Bluetooth with your mobile, your laptop, and they work. So if you have developed the calibration, as soon as you scan, you will get the data to ensure, because in outside that reflection is high. So you can ensure, like same sample you scan 2-3 times. Scanning only take less than a minute, like some seconds. So not a big process. You can scan 5 multiple times and ensure that whatever results you are seeing is the right result. Sometimes because of scanning, you will see the variations in results. So sometime back with Walmart project, we did buyback policy in Anantapur. Anantapur is a district in Andhra Pradesh where groundnut production is high, and also the industries are there which buy this groundnut. So to promote Girnar 4 and 5, we gave to farmer and we asked them to multiply and bring it back. So, and then when they got it, we don't know is actual Girnar 4 or 5 or not. So we need to test, and if the farmer from far villages, they bring the samples, and they cannot wait till our wet lab comes. So we use this mobile sensors immediately, and we found only 10% of farmers got the pure Girnar 4 and 5. Most of them, they mixed it. So if their previous plot have K6 or the local varieties, or the next plot or something, they were not very careful, they mixed it. So as soon as the mixed seed come, that oilic acid reduced, like it is not even 70, like it reduced to 50, 55. So whenever they're lower value, we know that it is mixed. So those who got the pure one, premium price was paid, but then farmer catch it very quickly. Next season, most of them, they got the pure one. They know the premium price will not be given to them if that is not pure. So in that way, you can enhance, you can you can make the value chain very fast, and adoption also very fast. This is the calibration side if you want to go. So this is the kind of distribution we take. If you have to make a good calibration, you always select the sample which has the representation. So mung bean has 20 to 30% of protein, and you can see we selected the sample from all the ranges. This is how training set look like, an auto validation set, and this is the independent set, which I was saying blind set. So blind validation is very important. That will give you extra confidence on your calibration. Otherwise, this sometimes you have a very good calibration statistics, but the prediction is very nasty, very ugly. So that's why blind validation will ensure the quality of your calibration. So you see that we ensure that blind validation, the independent set is like, so it was poor, we reworked on model, and you can take help of AI. There are ANN model, random forest is there, which, or the gradient boosting, GPS is there, which will give you a very good calibration method. Sometimes we also, just to accept that AI is not answer to everything. So sometimes statistical model, we find it better than those machine learning models. So depends case by case basis and expertise what you have. If your statistical normal or conventional method is giving better calibration, just go for it. This is also, we tested each time, you don't have to powder it. So we also tested on grain. So directly grains were scanned, and you see that with that also we have a very good accuracy. So need not to grind the grains. So sometimes breeders have very small quantity of seed. So we scan them, we give them protein value, and we return their seed. Same seed they will advance to next generation. So in that way they find it very useful that seeds are returned along with the value. So this is our multi-species calibration, because you cannot build calibration if your institute or organization is working with 10 different crops. Each time you cannot make 10 calibrations. So with that, we came up with multi-species calibration, and that was a good success. We were able to publish, and we are still using. So you see all the legumes are on higher side and all the cereals are on lower side. So what we did to test, if I have 10 crop I used in making multi-species calibration, whether if tomorrow I get 11th crop, whether I can predict it or not. So I built the calibration where wheat is involved, and you see the wheat validation was quite good. But then I built a calibration where wheat was not involved, and then I did the prediction. That was also not so bad. So it all depends. Related species always work well. So if you are making multi-serial calibration, just be ensured that sometime it like it will be not greater accuracy, but this accuracy is also quite good. So you can use it, this kind of calibration, for if some rough estimate is required for some crops, you can use it. This is like minor millets, so always there is a very less genetic variation for them. So we mix those, like we use this different 4 type of millets, and we build multi-millet calibration. And you say that their prediction accuracy is also very good for this. This machines also help you in online in real time tracking the how the nutrition partitioning happening. So you see the 6-wax sampling, leaf and stem has like higher nitrogen, means protein, higher protein content, and as soon as panicle has formed, all the nitrogen has translocated to the panicle. So you see the first from stem almost give everything to grains, and then from leaf. So you see there is a variation in leaf, how they translocate, and then at the maturity, all the nitrogen from the biomass has passed to the grain. So this kind of study also we do it with this, and this is only possible because we are able to use NERS sensors. So all the research study, right now these are the calibrations available with us. If anybody likes to have sample analyze, we can do it. Coming to X-ray, this sensors, I took longer time for NERS, but I'll go faster for this XRF and all. So X-ray NERS work 400 to 2500 nanometer, but X-ray based work below 400 nanometer. And that's why they can capture the inorganic form of the nutrition compositions. So you see that for iron and zinc, and now we are developing calibrations for calcium, which is important for finger millet and some crops. So this is also captured quite fast. Easy with XRF is that you can use pure metal to build your calibration. You don't need a wet lab data. So we have purchased the glass beads, which has a known concentration, 10 ppm iron beads, 20 ppm iron beads, 30 ppm iron beads, and you can build your calibration. based on that, you can always predict. So wet labs are like you can build with wet labs or with mm, pure metals. So both work well. So this is the flexibility working with XRF. So I think most of you know that now ICAR has made a obligation that to release new variety of pearl millet, they need to meet minimum requirement of iron 42 ppm and zinc 32 ppm. So below than that, the variety will not be released by the ECRIPS or the ICRs. So why this has happened? Because you see, this is the mini core collections of the pearl millet, which is representative of 10,000 accessions. And you see the level of genetic diversity we have for iron and zinc. And this blue one you are seeing is the release cultivars. Most of them not even having the half of that. Like, so release cultivars are very, very less in iron and zinc content. And to promote iron and zinc, because millet is eaten by the people in dry land, so to ensure their good health, the government has taken this decision, and we are fully supportive of that. You can see this kind of graphs are very provoking. You see all the release cultivars, nothing is matching even half. The variation is up to 140. The maximum has reached 80 or 40, 60. So this is like 1/3 what is variation we have. That's why they made a decision that at least this is also very minimum, 32 and 42 is like not big, difficult to achieve. So that's this XRF. On season, our machines are super busy because not only ICRISAT, but all the equip material, most of the from South India is coming here. So you see the variations we have in PMI gap, like, okay. So, and they are related. Iron and zinc content is related up to an extent. It is not very tightly related because iron is in top layer and zinc is in bottom layer. So processing also affect your assessment. So if processing of grain threshing and all this is very much metallic based, sometimes it affects. So iron is very sensitive to assess, and sensors are best like, yeah, we sometimes struggle with sensors also, but with proper SOP, you can still have a proper control of this. Coming to the third sensor, computed tomography. So tomography is a 3D X-ray based technology and mostly used in medical. You might have seen doctor prescribed CT scan. So this is the same in agriculture. Only few pioneer organizations are using so far, but it is widely spreading. It is beautiful technology for post-harvest assessments. It's very fast. So this is like some of the traits like shrivel seeds, uh, breakage grain, store grain pest, chuckiness, chuffiness, those kind of things are very easily accessible. All you have to do is take us image and then develop the any machine learning based image analysis based pipeline, which can translate your image into data. So for groundnut, we have done for 4 traits. It's like kernel weight, kernel grade, shelling percentage, and shell weight. So you see that maybe from outside the spots may look same, but the kind of filling they have is very different. So to assess the selling percentage, it is the good technology, and again it is non-destructive. You don't have to break or shell your pots. You just scan it. So this is just a glimpse of our image analysis pipeline, how we assess. So it is density based. And then this is the accuracy with which we are predicting. So actual kernel weight and predicted one. So you see that it's like quite good, like, and the mean absolute error is also very less. And then we have also developed for grade. So grade is something like there are 5 grades, commercial grades in groundnut. Best quality grades will go for very high price for confectionery, and for lower quality go for oil because they crush it. So grade is something giving extra wings. So imagine if groundnut breeding has to do these 4 traits, shelling percentage, it will go to one table. Then for grade, it will go to another table. Then for kernel weight, it will go to like altogether at least 2-3 decks, and it will cost. So when we did the cost calculation, we found that it is $8 when you go for this assessments of 5 trades. But if you go for CT, it costing only $2. So there is a 1/4 of your cost cutting. And at the end, we are returning those pods. So breeder for groundnut sowing, you need to keep it in pod. If you shell it, you can't use it as a grain if it is not just next day. So similarly for companies, we did for this hydrized recovery, chuckiness and chaffiness. So you can see that these assessments are also quite fast. Otherwise, it will go for 3 tables, 3 set of people to assess this. One scan and you are done. All your, and then you can take back your seeds also. So Harvest Master is the same, like it's a very portable technology, very useful. A lot of outside world has adopted very fast on this. So they attach it to thresher, they take it to field. So when they are weighing, so this gives 3 traits. It gives the weight, whatever grain you will put in that weight, moisture content of that, and also it will give the test weight, which is important. So right now we have calibration for all our crops, mandate crops, and also the major crops, and those calibrations are quite good, and it is helping breeder to correct for the moisture. So actual yield you can assess. Sometimes one variety is when you harvest it, it is at 14% moisture, and one is at 12% moisture, and 14% one is giving you greater weight, but actually maybe the yield is less compared to 12%. So this is the advantage. It will bring you precision in your breeding selection, and precision is genetic gain. If you see the genetic gain formula, so precise estimations will give you a better genetic gain. So coming towards the end, so advantage of utilizing the sensor, it's fast, it's cost effective also. One-time investment is there, but then it will serve for years. It's non-destructive, so minimum sampling is required. Like for NERS, we only need 20 grams of samples. For XRF, we also need 20 grams of sample. For CT, we need 100 grams of sample. So this is very minimum requirement. Scanning time is very less. It can do for multiple trades. So like in NERS, I was saying, for groundnut, we have 6 trades, 4 fatty acid, moisture, oil, and protein. So this many trade at one time, one scan, and all these 6-7 trades, you will get the data out of that. So multiple trades. Otherwise, you imagine one day you will send to Zeldal, one day you will send to Suxlet, and it will take a lot of time. So this is like multi-component can be analyzed at one time. Similarly for CT, chuckiness, chaffiness, hydrized recovery, one scan, and you have all this data in your Excel. Large scale analysis in short time, yeah, it's a multi-species calibration is possible. Sensors can accelerate the nutrition inclusive breeding. I think if we have to fight with the nutrition problem, we have to opt for the sensors. Only thing, as a researcher, you have to ensure that your sensors have a best calibration, quality calibration, so that you can give a quality results. Otherwise, sensors are black boxes. They will give you some data, and you have no idea whether it's accurate or it's wrong. So just be careful on that. With care, like with mindful usage of sensors and AI, we can serve a better product. Yeah, this is all. So thank you, everyone. This is my email ID. If you have any query, you can always reach out to me. Thank you.
किसी पार्टिसिपेंट्स की कोई क्वेरी है जो अभी तक 250 पार्टिसिपेंट्स टिके हुए हैं इस बेहतरीन लेक्चर को सुनने के बाद, यदि आपके जहन में कोई क्वेरी है इस पर्टिकुलर टॉपिक से रिलेटेड, तो आप बिना राजनीति के क्वेश्चन पूछे विषय वस्तु पे बात कर सकते हैं। जो भी पार्टिसिपेंट्स, हमारे फैकल्टी, साइंटिस्ट, पीएचडी स्कॉलर्स, पोस्ट डॉक, जो भी बात करना चाहें, प्लीज आपका स्वागत है। आप अपने आप को अनम्यूट करके डायरेक्ट बात कर सकते हैं। एडमिन आप सभी को जो है बोलने की अनुमति दें। किसी की कोई क्वेरी प्लीज आप चैट बॉक्स में भी टाइप कर सकते हैं। नंदिनी, आप उस क्वेरी
If
को मैडम
anyone
तक
is having any query, they can also type or they can also unmute themselves.
मैडम ने
Please type
लेक्चर
your
ही इतना
questions.
बेहतरीन दिया कि उसमें कोई क्वेरी रखी ही नहीं उन्होंने। तो हो सकता है कि पार्टिसिपेंट्स हमारे सोचने में विवश हो रहे हों।
Usually we hurry to ask the questions, so just give them time. When I'm also sitting in audience, sometimes question doesn't come very quickly, so it's okay to give some time. Or I'm sure it was not that great that nobody has question. Either it is too much of sensors that people didn't get it, or maybe it will click later to them. So how many total participants you have?
500 प्लस हैं, 300 अराउंड यहाँ ज्वाइन किए थे, 100 प्लस यूट्यूब पे ज्वाइन करें, लगभग 400 पार्टिसिपेंट्स इस लेक्चर को सुन रहा है। नंदिनी जी, कुछ क्वेश्चंस चैट बॉक्स में आए हैं, आप मैडम तक पहुंचाएं।
Yes, sir. Any sensor available for detecting or identifying the soil harmful or beneficial organisms?
For microorganisms, and this is not my subject area, so I'm not fully aware, but NIRS, they are using for soils also. For microorganisms, I think there is a lab in Equisearch, they do work. I'm not sure what sensors they use for this.
Crop advisory for millet crops.
Advisories are like mostly through the softwares. They have developed different tools to add the advisories, but I'm not sure what advisory for millet crops. What does it mean? Like maybe if
Can you predict storage life in godowns based on these sensors?
storage, yeah, this is something interesting we are working on. So with Dream Bank, um, so every year they have to invest a lot of money in germination test, and sometimes they don't get the proper hold of the age of the samples. So we are using accelerated aging chambers, and we are developing calibration which can predict the age, and for some crops just if the embryo is viable or dead. So that will help them without germination test. They can assess if the sample has a 80% of viability, means you are good, you can take one more year to multiply them. If they have reduced to 50%, 40%, they can take the uh, multiplication immediately. So like that, to make this kind of informed decision, we are developing with CT technology, the germination seed viability we are assessing with that. So similarly for storage you are asking, so yes, age can be done, and also if any kind of brookids or those kind of store grain pest infestation, like seed is healthy, but then because of pest it is like if you want to assess that also you can do. And for that, thermal sensors also in store grain storage we are using, like it scan and it gives if any live organisms are there in your heap of grain, that will detect, because their body temperatures are different than the grain temperature. So it's very easily detectable. If you feel in your storage some corners having infestation is increasing, with those thermal sensors you can easily scan it. But these facilities are only in few storages, not everywhere. So two or three kind of technology you can use for storage.
Can we identify the pollination processes through this sensor?
Pollination, it depends. Some flowers, once they pollinate, they change their appearance. That is visible through eyes only, like in cotton. But then there are like peas and all those. There is a very minor changes. You can do it, but I'm not sure that is the best use of sensors to do that one.
Okay, is there any sensors that can check germination percent and purity percent in seed?
Germination, yes. For purity also, like if you define what is impure, Like if your impurity is like other material, then it's fine. But if your impurity means the other variety seeds mixture, then it's difficult to develop the algorithms, to define the algorithms like this is particular variety and this is not particular variety. That resolution we have not gone up to, but any mixtures, inert materials you can identify. So yes, both germination and this kind of inert mixtures you can identify. It's very easy.
In India, how much percentage of farmers use sensors directly in farming now?
Very less. No, not. It's not reaching to farmers. It's like so far industry and aggregators. It is only reach up to that. It's even ICRISAT want that if this technology either farmer can use or the industry can use. If farmer use, if their produce is of good quality, like higher in protein or zinc, some reason or specific where high quality material is coming, then they can demand premium price for their produce. But it's happening in other way. Aggregators are faster in this technology, adopting this technology, so they are using to reject the material. If suppose if they find, industries are finding that this material is like for making a bread, they need a high gluten or something, so if they find it is lower in that side, so they are rejecting. So this is the drawback, like farmers are not very pro to adopt. When I was in Kenya, I saw the farmers, this NIRS, they were using for milk quality assessments. And that eProd is a small startup that will use this sensor. So it will give the quality of milk, and also it will give the small certificate, like a small printout. So taking that, those farmers, they will go to industries, milk, dairy industries, and they will ask higher price. But that kind of system establishing in India is not very easy. Neither farmers are pro for that. Like so, this is the adoption of technology is very very slow. It's not like technology is not there, but somehow culturally we are very restricted to use new things, especially on farmer sides. So this is the challenges in adoption.
Next, please.
Till what extent the results obtained from the sensors are reliable?
Yeah, that's what I was across the presentation. I was emphasizing how good calibration and blind validation it can be done. Over time, you learn that if your predictions are good, automatically breeder will come back and they will say that it's like. But from my side, I ensure my validations are very good. Until it is like above 90%, I don't take any samples for analysis. Like so, your honesty will only decide how good you can serve with the sensors and how much reliable they are. Like, but otherwise, sensors are very like a spectral signature. What they capture, it's like very authentic. Like Spectra cannot lie.
Is it possible to detect aflatoxins?
Yeah, this is something we are also trying, but aflatoxin contents are in ppb, in parts per billion, is very very small amount. One of the direct aflatoxin, because the aflatoxin, when you go to biochemistry, it is like it is in different structure and form, different types are there. So one of the secondary metabolite which comes out of this pathway, we are trying to capture that rather than whole aflatoxin is difficult, is not coming easy way. So the secondary metabolite, which is indicator of aflatoxin presence and also the quantity, we are trying to optimize that one. It's not done so far. It's not easy.
Can we identify pesticides residue in fruits and vegetables through the sensor?
Very, very easily. So most of the pesticide residue is having arsenic, lead, or aluminum. If you so XRF can be used. Like if you optimize the calibration for this, you know that how much pesticide residuals are there in those grains.
I think that's all.
Mm, yeah.
Is there any other question? You all can type.
मैंने पहले ही बोला कि मैडम का बहुत बेहतरीन लेक्चर था, लोग क्वेश्चन कर ही नहीं पा रहे हैं उस पर।
I think, yeah, we can close the session now.
नंदिनी,
Okay. Okay. Thank you so much, ma'am, for this illuminating session, which connected all of the important things. The way you shared humbly you shared all of the details and humbly you answered all of the questions makes you special for us. And we are very, very, very grateful for your presence. Please be connected for any future activities of Agreement Foundation. Thank you so much for your presence.
Thank you. Yeah, if 5% of people also got the message, I feel my presentation is useful. So thank you for giving the platform and connecting with people. It's really nice talking here. And you give sufficient time. Nowadays, everywhere, like, it's always short of time to explain things in detail. So I'm happy to be part of this. Thank you.
थैंक यू सो मच मैडम, थैंक यू,
Bye-bye.
बाय।